Hello guys, welcome back to a new video. We have sample problem 2b. In the previous lesson, we talked about stress, strain, and Young's modulus. In these problems that we have, we are going to use how can you use this equation and calculate each of the problems that you have. Okay, now look, it says a steel wire of diameter 0.4, 0.40, sorry. Now, whenever you have diameter, guys, whenever you have diameter, so diameter is equal to 0.040, or just basically 4 millimeter. If you remember, the diameter of a circle is equal to the length from edge to edge. Okay, this is diameter. Okay, the radius is what? The radius is half of the diameter. So from the edge to the half of the radius, this is called what? This is from the circle. This is called the radius. Okay, whenever you have diameter, you should always change it to radius when you are dealing with questions regarding to strain, stress, and Young's modulus. So D will be what? Sorry, R will be diameter divided by 2. So you have 0.4 millimeter divided by 2. Okay, this one will be what? This one will be 0.2 millimeter. Okay, and change this millimeter to what? To meter. Okay, so radius will be what? Radius will be 0.2 times 10 to the power of minus 3 meter. This is what? This is radius. Something else, guys, whenever you have radius, always use it to find area. Okay, whenever you have radius, when you find the radius, try to use it to find area. Okay, it says what? Initial length is equal to 2 meters. Okay, if it says length only, it's initial length, even if it doesn't say initial length. So initial length is equal to what? Initial length is equal to 2 meters. Okay, 2 meters. This 0 doesn't make any sense even if you write in the calculator, so it's basically 2 meters. Is suspended vertically from a fixed point and a weight of 80 Newton. If you have Newton, it's always what? It's always force. So tension, we only had one variable which had the unit of Newton, which is what? Tension. Tension is equal to what? 80 Newton. Okay, is connected to a slow end. The resulting elongation. So elongation is what? Is 6.4 millimeter. And yeah, guess what? You'll change it to meter. 6.4 times 10 to the power of minus 3 meter. Guys, it says what? Calculate Young's modulus. You can do this in two ways. First, find stress. Okay, stress is what? Tension over area. And you have radius, find area. Or you can basically plug in all the values in Young's modulus. So let's do it like this. You will say Young's modulus is equal to tension multiplied by initial length divided by area multiplied by elongation. This is equal to AT multiplied by what's initial length? 2 divided by, do I have area? No, I don't. Now I have to find area. Okay, let's find area. Okay, I'll try to do it here. Whenever, I told you, whenever you have radius, whenever you have diameter, change it to radius and find area. Area of a circle is what? Is equal to pi r squared. Okay, then A will be what? Will be 3.14 times, what was the radius? 0.2 times 10 to the power of minus 3, and all of it squared. Okay, this is for finding area. then you will have what? You will have area which is equal to 1256 times 10 to the power of minus 6. So you basically multiply this by this, and then you will you'll multiply 0.2 by 2, okay? 0.2 multiplied by 0.2. Now you have 0.1256 times 10 to the power of minus 6. What's the unit? Meter squared, okay? If you get 10 to the power of minus 7, it's okay. You can get it like this, 1.2. Just put it in, and the final result is important, okay? Doesn't matter how you get it. Then, this is what? Careful, this is area of a circle, okay? Not a rectangle, it's area of a circle. Now, did I find the area? Yes, then put it here, okay? Put it here. You have 0.1256 times 10 to the power of minus 6. This is area. Then multiply this. Did I have elongation? Yes, I had. 6.4. This is the elongation. 6.4 times 10 to the power of minus 3. Okay? Now, calculate this, and Young's modulus will be what? Will be 2 times 10 to the power of 11. What's the final unit? Pascal. Okay? Never forget to write the unit. Okay? This is sample problem 2B. Okay? We have these questions. Okay? Question 1, it says a metallic wire of diameter. You have diameter. You guessed it correctly. You should change it to what? To radius by dividing it by 2. Then you'll find area with it. Okay? So we have diameter is equal to what? Diameter is equal to 1 millimeter. Okay? Radius will be what, guys? Radius will be diameter over 2. So you have 1 millimeter divided by 2. You have 0.5 millimeter. And then change this millimeter to what? To meter. So you have radius is equal to 0.5 times 10 to the power of minus 3 meter. This is what? This is radius. And I will use this radius to change it to find area with it, okay? Then you have what? Length. Whenever it says length, it is what? It is initial length. It's the same thing, guys, okay? Initial length. It will tell you if it's elongation. So if it says only length, it is what? It is initial length. It's equal to 2.3 meters, okay? You have also Young's modulus, guys. It says Young's modulus is equal to 1.1 times 10 to the power of 11, okay? So you have Young's modulus. You don't need it here. You need it in the second question, but let's write it here. 1.1 times 10 to the power of 11 Pascal, okay? This is Young's modulus. A, it says what? A, it says calculate the cross-sectional area of the wire. Cross-sectional area of the wire, okay? So you need what? It says area is equal to what? Do I have everything to find area? Yes, I have. So you'll say area is equal to pi r squared, okay? This is why we always change diameter to radius to find area with it, okay? So you will say area is equal to pi is 3.14, okay? Or if you have the calculator, you can directly write pi and multiply by r. Multiply by, you'll get a more precise result like this. 0.5 times 10 to the power of minus 3 all squared, okay? Then area will be what? Area is equal to 0.785 times 10 to the power of minus 6 meter squared. Or if you want to put this decimal here, you can say area is equal to 7.85 times 10 to the power of minus 7 meter squared. Okay, this is what? This is for B, calculating the area. What about B? Okay, B, it says strain is equal to what? Okay, let's see. It says strain is equal to what for an elongation of 0.85. So you have elongation, which is equal to 0.85 millimeter. Now you should change this to what? To meter. Okay, this is equal to 0.85 times 10 to the power of minus 3 meter. Strain is equal to what, guys? Is equal to elongation divided by initial length. Did I have initial length? Yes. Look at here. We wrote this here. Do I have elongation? Yes. So you'll say 0.85 times 10 to the power of minus 3 meter divided by 2.3 meter. Calculate this number. Yeah, you remember? You remember we said meter cancels with meter? Okay, so this gives me what? This gives me no unit. Strain doesn't have any unit. Calculate this number and then you'll get 0.37 times 10 to the power of minus 3 no meters. Okay, careful. And then, or you can put this decimal here and you can say 3.7 times 10 to the power of minus 4. Okay, we found area. Careful, we need this. We found area and we found strain too. Now question 2 says what? Question 2 says, in exercise number 1, calculate the stress of the wire and the force needed to cause the stress. So you need what? It says stress is equal to what? And tension is equal to what? Okay? Now it says in exercise number 1. So we had area, which was equal to what? Area is equal to 7.85 times 10 to the power of minus 7 meter squared. Okay, we had strain, which was equal to what? 3.7. It's 3.69, but you make it 3.7 times 10 to the power of minus 4. Remember, we had something else. We said we're not going to use it in question 1. We had Young's modulus. Young's modulus is equal to what? Is equal to 1.1 times 10 to the power of 11 Pascal. Okay? It says calculate stress using all of this. Okay? To find stress, remember we said sometimes we use the longer equation for Young's modulus, or we use the other one. So Young's modulus is equal to what? Can I find stress? Can I find stress using this equation? So stress is equal to what? Is equal to tension over area. Can I find stress using this equation? No, because I don't have tension. Okay, I have area, yes, but I don't have stress and I don't have tension too. I cannot use this equation. I'll use the other equation. I will say Young's modulus is equal to stress divided by strain. Okay, rearrange this equation. Okay, multiply this by this one and you'll say there is 1 here, cross multiplication. So you'll get what? You'll get this one. Stress is equal to Young's modulus multiplied by area. Okay, then you have what? You have stress. Young's modulus is equal to 1.1 times 10 to the power of 11 times area is equal to what? 7.85 times 10 to the power of minus 7. Then what will be the final result? Stress is equal to what? Stress will be equal to 7.07 times 10 to the power of 7 Newton meter squared or Pascal. Okay, this is what? This is stress. Okay, you found stress. Now it says calculate tension. Now let's use the other equation which we have tension. Okay, so tension is equal to what? Stress is equal to what? Is equal to tension over area. Okay, tension over area. Do I have tension? Yes, I have. Okay. Just a mistake here, guys. This is not area. Sorry. Let me correct this one. This is not area. This is strain. Okay. So you have stress, which is equal to Young's modulus 1.1 times 10 to the power of 11 multiplied by 3.7. You'll use strain, not area, times 10 to the power of minus 4. The result will be 4.07 times 10 to the power of 7 Pascal, or Newton per meter squared. Okay, sorry for the mistake. Now you have stress. We found stress, and we have area. Okay. I will use both of these to find tension. Okay. Same thing. Let's say you have one here. Cross multiplication. You get what? You get tension, which is equal to stress multiplied by area. Okay. We found stress here. Okay. So you will say tension is equal to 4.07 times 10 to the power of 7 times area was equal to what? Was equal to 7.85 times 10 to the power of minus 7. Yes. Now tension will be equal to what? Tension will be equal to 31 point. These two powers will cancel because they have opposite signs. 31.9 Newton or 32 Newton approximately. Okay, this is question 2. Okay, now we have section review. Question 1. What is a strain in a wire of length 0.4 compressed by? Remember we said what? So let's say question 1, and let me use a different color. Remember we said not always it says initial length. Sometimes it just says length. So if it says length, it's what? It's initial length. So initial length is equal to 0.4 meter. Compressed by. This compressed by means what? Means elongation. L minus L naught. Okay, you have 0.05 meter. It says what? Calculate strain. It's very easy. Strain is equal to elongation divided by initial length. Okay, then you have 0.05 meter divided by 0.4 meter. Meters cancel, remember, always. Meters cancel, and you don't have any unit. This will be 0.125. This is the amount of strain. Question 2. This is question 1. Question 2, it says what? It says a metallic wire and the stress. So stress is equal to what? Is equal to 2 times 10 to the power of 7 Newton over meter squared. What force causes the stress? So it says what force, okay? We only have one force when we are dealing with stress, Young's modulus, and strain, which is what? Tension. So tension is equal to what? If you have cross-sectional area, if you have area, which is equal to 1.5 millimeter squared. There's a really important note here. Please pay attention. Because you have millimeter squared, okay? When you change millimeter, because you have meter here, your units should be consistent, okay? Your units should be consistent. You should not have millimeter here and meter here. You should change this millimeter to what? To meter, okay? Now look, you have 1.5 millimeter squared. Let's change this to what? To meter. You have 1.5 times 10 to the power of minus 3. But you have 2 here, okay? Careful, this is squared, okay? Then this one will be what? Multiply 2 by minus 3, you will get what? You will get minus 6. Okay, this one will be minus 6. Okay, and you have meter squared. Okay, if it was volume, let's say, just for your information, if it was volume is equal to 1.5 times, millimeter cubed. Then you'll say what? 1.5 times 10 to the power of minus 3. 3 multiplied by 3, you have minus 9. Okay, meter cubed. Okay, this is for better understanding. Now you have what? You have area and you have stress too. Let's find the tension. So stress is equal to tension over area. Let's say you have 1 here, cross multiplication. So tension will be what? Tension will be stress multiplied by area. Okay, stress is equal to what? So tension is equal to 2 times 10 to the power of 7 times 1.5 times 10 to the power of minus 6. 10 to the power of 7 multiplied by 10 to the power of minus 6 is 10. Okay, 2 times 1.5 is 3, so 10 is equal to 3. Then you have 10 multiplied by 10, 30 Newton. This is 30 Newton. This is question 2. Question 3. Question 3, it says given a bronze wire of length 2.5. Let me delete this so I can write here. Question 3. Question 3, it says, given a bronze wire of a length, remember we said if you have length, it's always what? It's always initial length is equal to 2.5 meter. Cross-sectional area, so don't be confused by cross-sectional area. You have area, so it's what? It's area. So cross-sectional area is equal to 6.5 times 10 to the power of minus 7 meter squared. What is the elongation? This time it needs what? It needs elongation. Remember elongation? L minus L naught is equal to what? If it is stress and a force, you have Newton, so this is what? Tension. Tension is equal to 10 to the power of 3 Newton. Young's modulus is equal to what? Is equal to 2 times 10 to the power of minus 11 Newton over meter squared. Pay attention. There is something important here that you should learn, okay? You have Young's modulus, which is equal to tension multiplied by initial length divided by area multiplied by elongation. Take a look at this one, guys. You need to find what? You need to find this one. You have all the others. You have tension, you have initial length, you have Young's modulus, you also have area, but you need to find this one. How can I rearrange this equation? Okay, how can I rearrange this equation? Okay, you will say, let's say there is E that has 1 underneath it. Then you have tension multiplied by initial length, area multiplied by elongation. Cross multiplication, this one multiplied by this one. Okay, then you'll have what? You'll have E multiplied by area multiplied by elongation. 1 multiplied by T multiplied by initial length is still the same. So this one will be this one. You need this one. You need to find elongation. So divide all of this by what? By E multiplied by A. Then the other side 2E multiplied by A. Then this one cancels with this one. The final equation will be what? The final equation, you have L minus L naught is equal to tension multiplied by initial length divided by Young's modulus multiplied by area. You had tension. Tension was equal to what? Tension was equal to 10 to the power of 3. Then you had initial length, which is equal to 2.5. You had Young's modulus, which is equal to what? Young's modulus is equal to 2 times 10 to the power of minus 11. Okay, so you have 2 times 10 to the power of minus 11 times you had area, which is equal to 6.5 times 10 to the power of minus 7. 6.5 times 10 to the power of minus 7. Calculate this one and you'll get, let's calculate it. You have 10 to the power of 3 multiplied by 2.5. Divide this by 2 times 10 to the power of minus 11 times 6.5 times 10 to the power of minus 7. So the final result will be what? Will be 1.92 times 10 to the power of 20. What will be the unit? The unit will be meter. Okay. This is it for today. See you in the next videos.